2.5 variation. So we're going to talk about varies directly, directly proportional, and constant of proportionality. So when something varies directly, it is multiplication because you're affecting it directly head on. You're not taking anything away from it, it's going towards it. So you're going to let x and y denote two quantities. All that means is you have x, you have y. So y varies directly with x, or y is directly proportional to x if there are a non-zero number k for which y equals k times x. K is called the constant of proportionality. So basically, to sum all of that up, if y varies directly with x is greater than 0, k is greater than 0, and this is what the graph would look like. It would go straight up. Note that the constant of proportionality is, in fact, the slope of the line. All right, mortgage payments. So what do we use variation for? Well, a lot of math is revolved around money. So the monthly payment P on a mortgage varies directly with the amount borrowed B. If the monthly payment on a 30-year mortgage is $6.25 for every $1,000 borrowed, find the formula that relates the monthly payment P to the amount borrowed B for a mortgage with these terms. Then find the monthly payment P when the amount borrowed B is $200,000. That is a lot. That's okay. So how do we know? Excuse me. How do we know if it's varies directly or indirectly? There's one key term. It says varies directly. So because it says varies directly, we know we're going to be using y equals k times x. But instead of y, it's p equals k. There's always the constant. It's always a k. Times b. How do we know it's b? Because it's payment varies directly borrowed. So you see how the varies directly, it tells us what formula to use, and then the left side of the varies directly is the y. The right side of the varies directly is going to be your x. Sometimes you're given a constant, but most of the time we're not. So it's telling us that the monthly payment, and that stands for P, so the monthly payment on a 30-year mortgage is $625 for every $1,000 borrowed. So the payment is $625. We don't know the constant, that's what we're trying to find. And then it's saying for every $1,000 borrowed. So that's borrowed B. So we have $1,000. We're going to solve for k by dividing by 1,000. So 6.25 divided by 1,000 equals k, which is 0.00625. Right, you move the decimal places 3 times. And that's what our constant is. So the model, that's actually what we just found. Once you find the constant, you find something called the model. Now the model is a formula that represents what we're going to plug into it. So like y equals mx plus b, that's linear model. But model goes into more specifics of this exact example. So the model that we're going to start using is p equals 0.00625 b. So now that we have the model, we can go ahead and answer, find the monthly payment, so we need to find P when the amount borrowed is $200,000. So we have borrowed is $200,000. So we need to find what that monthly payment is. So we do 0.00625 times 200,000, and we get the monthly payment of $1,250. Now what that means So if you borrow $200,000, your monthly payment is $1,250. What does that mean? Well, like, that means, like, so you bought a house, it's $200,000, you got a certain interest rate, and now your monthly payment is $1,250 a month. So, extra information. You do not need to know that. This is just extra information for me to tell you. So, some extra information. You know, when you borrow money and you get a loan, you know, there's something called interest rate. So, the interest rate for this loan is 6.25%. That's what an interest rate means, is how much every $1,000 are you going to be charged. So every $1,000 you're going to be charged $6.25. So that's why it's a 6.25 interest rate. This graph illustrates the relationship between the monthly payment P and the amount borrowed B. So you can figure out using this model, using the model that we found, you can figure out how much it's going to be. So you can use this to figure out, well, what if I want to do a $250,000 house? You know, where am I going to be at? And this is what that means. So that this is our $200,000 borrowed, and that's our payment of $1,250. Alright, so this is directly proportional and then inversely proportional. So it's the opposite. So let x and y denote two quantities, then y varies inversely with x, or y is inversely proportional to x, if there is a non-zero constant k for which y equals k over x. So meaning, if instead of that word of varies directly, if you see varies inversely or inversely proportional, we're doing y equals k over x. This graph is what it would look like. So when we graph something that is inversely proportional, it's going to like swoop down like this. Alright, maximum weight that can be supported by a piece of pine. The maximum weight W that can be safely supported by a 2x4-inch piece of pine varies inversely with the length L. Experiments indicate that the maximum weight that a 8-foot long 2x4 piece of pine can support 400 pounds. So what it means is you have an 8-foot long piece of wood, but it's a 2x4. So 2x4 is what they use to like build houses and stuff like that. It's like those atypical long pieces of wood that you would normally see, not the flat boards, not those. The, you know, like when you think of like a brick of wood, a really long one, that's what we're talking about, but it's 8 feet long. We're going to write a general formula relating the maximum weight W in pounds to the length L in feet. Find the maximum weight that can be safely supported by a length of 20 feet. Cool. All right, so we know because it says varies inversely, we're going to be using our formula of y equals k over x, or something similar to that. But instead of y, so the part before that term varies inversely, we have weight. So we have w, that's going to happen. Alright, sorry. We have w equals, we don't have our constant, it would say k over, so the second part after varies inversely, so it says varies inversely with its length L. So we'll have L. So our model is going to be represented by y equals k over L. So we need to figure out our constant. So in this first piece of information, it tells me that we have a weight of 400 pounds. And the length of the piece of the wood is 8 feet long. So we're going to solve for k here by multiplying by 8 to both sides. And when we multiply by 8 to 400, we get 3,200 equals k. So that's our constant. Now our formula we're going to use, the model, is W equals 3,200 over L. So now that we wrote the formula, let's find the maximum weight. So let's find the weight if the length of the wood is 20 feet. So we have our length of 20, our weight, we don't know, we're trying to find it. Just in case it's been a while, remember we can cancel out zeros. So now we have 320 divided by 2, so we have the weight is 160. So the max weight for a 20-foot 2x4 is 160 pounds. So if you had a 20-foot 2x4, so imagine a 20-foot piece of wood, you can walk across it if you're less than 160 pounds. And that's what this graph represents. So when we have a 20-foot, it's 160 pounds. When we have an 8-foot, it's 400 pounds. Cool, right? Because you have to think, the longer it is, the more fragile it is, right? Alright, our next example, from here, we're just going to make the model. We're not going to try and solve anything. We're just trying to make the model, because this is joint variation. So now we're going to apply inverse variation and direct variation. So a student GPA varies jointly with the average amount of time he or she studied each week and the average amount of time sleeping each week, and varies inversely with the average amount of time spent on social media each week. Write an equation that relates these quantities. So let's just take out what they're saying. This is this, this is this, all this. So let's take out every part of information they gave us. All right, so we're talking about a GPA. So we're going to say that's a G. So that stands for GPA. We'll get to the varies jointly. Let's just take out our syllables, or not, our variables. So it varies jointly with the average amount of time he or she studies weekly. So we'll say that's S, because that's studies. So that's average time, let's say studying. And then it says the average amount of time spent sleeping. So I made that R. And it varies inversely with the amount of time spent on social media. So that's our next variable. So we'll say F. Alright, so now that we got all of our objects out, like the things we're talking about, we can put it into our inverse, our joint variation formula. So we don't actually have one, we have to come up with it. Alright, first things first, it says a student's GPA varies jointly. So that means it's G equals the amount, with the average amount of time he or she studies each week. So we need a constant in here. And since it says varies jointly, we're going to put our K on the side. So our next variation that we're talking about is varies inversely. So varies inversely means we have our fraction bar, and now we're going to go back through the sentence. So we have the average amount of time he or she studies each week, so that represents S, and the average amount of time spent sleeping. So you see how that in between it has an and, it doesn't have an inverse or directly, it doesn't have any varies word, so that means you keep it on top. So time sleeping is R, and that each week, so time spent sleeping each week varies inversely with the average amount of time spent on social media. So that's why it goes on the bottom, because of now we have that word varies. So we could use this model to determine what your GPA would be if we figured out the average amount of time you sleep, average amount of time you study, and average amount of time you spend on social media. Cool. Cool, right? All right, last example. The force F of a wind on a flat surface positioned at an angle to the direction of the wind varies jointly to the area A of the surface and the square of the speed V of the wind. A wind of 20 miles per hour blowing on a window measuring 3 by 4 feet has a force of 120 pounds. What force does a wind of 40 miles per hour exert on a window measuring 4 by 5 feet? So we do not have a constant here. We have to find it. So let's figure out how we're going to bring all of our information out. So it's saying F, the force of F of the wind, so F, on a flat position at a right angle to the direction of the wind varies jointly, so we have equals, because that's the first time we saw varies, with the area, so with the area on the surface and the square speed v. So square speed v is v squared, because it says the square of v of the wind. What are we missing here? Because did it say inverse variation or direct variation? It didn't say any of that. So all we're missing is our constant, which we just put on the side. Your constant is always going to go on the side of something. Alright, so F represents the force of the wind. So the force of the wind is 120 pounds. And it equals the area of the window. So the window that we do know right now that we have is 3 by 4. So we do 3 times 4, which is 12, times v squared. So v represents the speed, and it's saying speed, so speed is like miles per hour or kilometers per hour. So it's 20 miles per hour, times our constant. So let's go ahead and figure out what our constant is. We have 120 equals, so use your calculator, do 20 squared, so that's 400. 400 times 12 is 4,800K. We're going to divide by 4,800. And when we do, we get, simplify your fractions always, 1 over 40 equals K. So that's our constant. That means the formula, the model that we're going to use is F equals A times V squared times 1 over 40. So now I want to know the force of a wind of 40 miles per hour and how much does that exert on a window that's 4 by 5. So we want to know the force of the wind of a 40 mile an hour, so 40 miles per hour, that's speed. And the area now is a 4 by 5, so 4 times 5 is 20, so we're dealing with an area of 20 feet. The speed now is 20 miles an hour. 40 miles an hour. Use your calculator. 40 squared times 20 is 32,000. And 32,000 divided by 40 is 800. So what this means, the force of a wind blowing 40 miles per hour at a 4 foot by 5 foot window is 800 pounds. So that means outside, if you have a 4 by 5 foot window, so a 4 by 5 foot window, that's like most windows, like by your front door, the big windows. That means if it's a 40 mile an hour wind outside, the pressure and the force on that window is 800 pounds.